Okay, during our class today we were working on rational exponents and solving exponential expressions. So let me change to my pen here. We're going to be working on this problem set here, solving exponential equations using exponential properties, and it's in Mathematics 2 in the rational exponents and radicals unit. So let's take a look at some of these. So what we really want to do is we want to find a common base. To solve these kinds of problems, we want to find a common base. Because when we look at this problem here, and man, it looks really complicated, and it looks really difficult. And like I said in class, part of math is knowing enough stuff to move the difficult problems into easy problems that we can solve. There's lots of problems in math that we can't solve the way they look, but we can move them into easier problems that we can solve. And we can do that here by finding a common base, a base that's the same. So we have 5 and 125, and I know 125 is a multiple of 5. So I'm going to choose the base of 5. So my first base I'm going to keep as 5 to the 7x plus 5. But my second base, let me do it over here. My second base, 125, is equal to 5, base of 5 to the third power. 5 times 5 is 25 times 5 is 125. So 5 to the third is equal to 125. So when I see 125 here, I'm going to write 5 to the third instead, and now I have a common base to the 2x minus 7 power. And now we can use that power of a power rule. So we're going to multiply these together. So I'm going to have 5 to the 7x plus 5 power is equal to 5 times 5 to the 3. God, this is ugly. Okay, let's try it one more time. 3 to the 2x minus 7 power. So now I have two bases, and the values are equal, so I know that the exponents are equal. So I can say 7x plus 5 has to equal 3 times 2x minus 7, which is 6x minus 21. And then I can just solve for that. And I'll get x is equal to negative 26. And when I type in x is equal to negative 26 over here, I'm going to get it right. Let's look at another example. And again, what did I say? We want to find a common base. For this kind of problem, we want to find a common base. Finding a common base will help us solve it. So over here I have 5, and I know that 125 is a multiple of 5, but 1 over 125, let's see if we can do that. So we know from before 1 over 125 is 1 over 5 cubed, but then I also know from my exponent properties that that's a negative exponent. 1 over the exponent is the negative exponent. So I'm going to use this, and everywhere that I see 1 over 125, I'm going to write that. So let's start there. 5 to the x minus 12 is equal to 5 to the negative third power to the 12/5 power. Wow, this is ugly. Okay, so let's simplify it a little bit. X minus 12 is equal to, and let's use power of power and distribute here. We're going to multiply these two together, so it's going to be 5 to the negative 36 fifths. Okay, so because I have the same base and these values are equal, I know that the exponents are equal. So I know x minus 12 is equal to negative 36 fifths, so I'm going to add 12 to both sides. And on this side, I'm going to make that into fifths. So that's 60 fifths. 12 is 60 fifths. 60 divided by 5 is 12. So now I have x is equal to 60 minus 36 fifths, which is 24 fifths. So if I write 24 fifths up in here, and I think you're going to have to do it like that, use that that slash that's below the question mark on your keyboard probably, then you should get it right. Let's try one more here. And what are we going to try to do? We're going to try to find a common base. Common base. We have the same base for both sides. This is going to be easier than you think it is. It looks kind of hard, but it's going to be easier than you think it is. This is 1. And I know that like basically any base to the 0 power is equal to 1. And this is not real math, right? But any base to the 0 power is equal to 1. So I can say that 9/8 to the 0 power is equal to 1. And now anywhere I see 1 over here, I can write 9/8 to the 0. So I'm going to do that. I'm going to start there. 9/8 to the 3x plus 12 is equal to 9/8 to the 0. And that 9/8 kind of maybe threw you and you weren't sure what you could do, but this really made it easy. So now we have the same base. It doesn't matter that it's a fraction. It doesn't matter what it is. But it's the same base. And they're equal. The values are equal, so we know the exponents are equal. So I know that 3x plus 12 is equal to 0. So 3x is equal to negative 12, or x is equal to negative 4. And then I'll go write x is equal to negative 4 in here. And then when I submit, I'll be done. And I'll get it right. And you will too. So best of luck with that one. The link to this problem set is in the description of the video.